Welcome to the Deep Dive, your shortcut to getting truly well-informed. You share your stack of sources with us, and we dive in to pull out the most important insights, surprising facts, and give you just enough context to feel like you've got a real handle on the topic.
Yeah, we sort through it all so you don't have to.
Exactly.
Yeah.
And today we are plunging into something really fascinating and honestly quite complex, the environmental footprint of the rapidly growing cannabis industry.
It's a timely topic, definitely.
Yeah.
And the sources you shared give us a fantastic range of perspectives to work with. We've got everything from a really comprehensive report by the National Cannabis Industry Association, the NCIA,
Right.
diving into policy and research. But
Mhm.
then we also have practical, hands-on wisdom from grow guides like Nature's Living Soil and Dutch Passion, and even community discussions from places like Reddit.
That blend is perfect for a deep dive, isn't it? You get the big picture policy issues, the science, and the sort of on-the-ground realities growers are actually facing.
hmm
And a huge thank you, seriously, for providing this material. It's what makes these deep dives possible for you. And also a genuine thank you to the researchers, cultivators, and community members whose knowledge is captured in these sources, especially the contributors acknowledged in that NCIA report and the team at Nature's Living Soil. It clearly takes a lot of work to pull together this kind of information.
It really does. So our mission today, basically, is to cut through all this material, pull out the most important nuggets of knowledge, and help you build a solid understanding of the environmental challenges and maybe the opportunities facing the regulated cannabis market,
Yeah.
from seed to sale, essentially.
From cultivation right through to processing and sales.
Hmm.
And it's a market that's just exploding, right? As the NCIA report highlights, even back in the summer of 2020, we were already looking at 33 states with medical laws, 11 with adult use.
Plus that massive expansion of hemp thanks to the 2018 Farm Bill.
Yeah. It's so integrated into the economy now that in many places it was even deemed essential during the spring 2020 lockdowns. Remember that?
Essential cannabis. It really highlights just how quickly this industry has become part of the mainstream economic and social fabric.
Totally.
But with this rapid growth and integration, the central question really emerges from these sources. How does this fast-growing, regulated industry address its environmental footprint? And, the big question, can it potentially even lead the broader agriculture sector in adopting truly sustainable practices?
That's the exciting potential the NCIA report points to, isn't it? But to get there, the sources make it really clear we first have to grapple with a major hurdle, something they call the shadow of the illegal market.
Exactly. The illegal market isn't just a problem for law enforcement or tax collectors. It's fundamentally an environmental catastrophe waiting to happen, or in many cases already happening.
And why is that? What makes the environmental impact of illegal grows so much worse?
Well, it really comes down to the drivers. The illegal market is driven almost purely by economic necessity, right? Maximizing yield with minimal overhead. Environmental concerns, they're often disregarded entirely. And the impacts are, as you said, dire, especially in vulnerable ecosystems.
Okay, give us some specifics from the report. What are the most concerning environmental problems from this unregulated activity?
Well, the sources highlight significant threats to freshwater resources, particularly in water-limited areas out west. Early studies, often focusing on illicit outdoor grows in places like Northern California.
Right, where a lot of it started.
Yeah, exactly. Those showed substantial potential stream flow reduction. They found that water diversions by these unregulated farms could easily exceed available stream flow, sometimes literally dewatering aquatic ecosystems entirely.
Wow. So it's not just about using water, it's about using water in a way that directly harms rivers and streams, potentially wiping out fish and other aquatic life, especially during droughts.
Precisely. And beyond water, the lack of regulation in the illicit market means zero oversight on waste management or disposal. That leads to pollution of land and water. You see uncontrolled land use practices like building roads on steep slopes without proper drainage, clearing land right up to stream banks, all causing significant land degradation, erosion, and habitat destruction.
So minimizing the illicit market isn't just about getting operators licensed. It's actually crucial for enabling environmental sustainability. The legal market, unlike the illicit one, is regulated. It has the structure, the oversight, the potential to implement and enforce sustainable practices. The key, I guess, is whether those frameworks are robust enough and widely adopted.
That potential is definitely there in the regulated space. Which brings us nicely to our first deep dive area, one that is absolutely fundamental to all agriculture: land use and soil health.
Land use and soil health. Okay? This section starts with a quote in the NCIA report from Jeff Wallen that really grounds things. We think we're here because of our big brain. We're not. Humans owe our existence to 6 inches of soil and the fact that it rains.
It's a powerful reminder, isn't it? Soil isn't just dirt. It's a living ecosystem that sustains us. And when we look at cannabis cultivation compared to traditional U.S. agriculture, there are some pretty fascinating distinctions in terms of land use.
Like the fact that marijuana production requires surprisingly little land overall compared to big commodity crops.
That's one key insight, yeah. The Rand Corporation estimated back in 2010 that the demand for the entire U.S. market could potentially be met with just 400 acres of outdoor production.
Yeah.
Now compare that to the national average non-cannabis farm size of, 448 acres.
Wow.
Or the truly staggering 500,000 acres licensed for hemp in 2019 alone after the Farm Bill passed.
500,000 acres of hemp. So while individual marijuana grows might be small, sort of craft operations, the sheer scale of hemp cultivation, which is the same plant, remember, can quickly add up to significant agricultural land use, pushing those overall numbers way, way up.
It really highlights the distinction the sources make between marijuana,
Yeah.
often higher value, smaller scale, maybe more labor-intensive craft production, versus hemp, which is treated more like a standard commodity crop, large scale and mechanized. And this difference profoundly influences land use practices.
And then there's a whole split between cultivation methods, indoor, outdoor greenhouse, which is often dictated by state regulation or just the climate. Some states, like Colorado, apparently started with a heavy focus on indoor due to regulatory burdens and security concerns.
Right.
While hemp, being legal federally, can be grown outdoors in agriculturally zoned areas much more easily.
And these decisions about where and how you grow have these sort of cascading environmental impacts, starting right there with the soil. Regardless of the method, conventional, unsustainable agricultural practices, particularly in water-limited areas or on vulnerable slopes, can severely degrade soil health. We're talking about loss of essential nutrients, reduced ability to absorb water, that's permeability, and a decrease in vital organic carbon.
Which makes the soil less fertile and more vulnerable, leading us directly to erosion. The sources define erosion pretty clearly. It's the process where soil particles break down, detach, and are transported and redistributed by water, wind, or gravity. Simple definition, big consequences.
And the environmental concerns are significant. Erosion leads to dust emissions, and maybe most importantly, the runoff of sediment, nutrients, and chemicals into water resources. That harms aquatic life and water quality downstream. Beyond just losing valuable topsoil, erosion directly harms crop emergence, growth, and yield, and it removes organic matter and any applied amendments that the plant actually needs.
The report specifically details water erosion, noting it's caused by excess water on slopes and is often highest during the spring when soils are saturated and there's minimal vegetative cover. Things like the energy of raindrops hitting the ground and the amount of runoff are key factors.
And here's a fascinating little detail from the source that kind of surprised me. Did you know even something as basic as soil texture can dramatically impact how much a farm is prone to erosion?
Really? How so?
The source points out that coarse textures, like sandy soils, are actually more susceptible to erosion than fine-textured soils like clay.
Huh. That's counterintuitive. You'd think looser soil would just wash away more easily. But that's a great nugget for you. So soil fertility and resilience are also key concepts the sources delve into.
Yeah, fertility is basically the soil's capacity to support plant growth, which is intricately linked to overall soil health or quality, its physical, biological, and chemical properties all working together. Resilience is its capacity to recover and bounce back after disturbances.
And what kind of disturbances are we talking about here? Natural ones? Human ones? Both?
Both, definitely. Natural
Yeah.
events, like floods or fires, sure. But the sources are quite clear that agriculture itself, if it's not managed sustainably, can be a major ongoing stressor and disturbance to the environment.
And poor cultivation practices, things like over-fertilization, maybe excessive tillage, which disrupts soil structure, overwatering, which is common, and soil compaction from heavy machinery, all these can negatively impact both fertility and resilience. They undermine those absolutely vital soil ecosystem functions.
Like sustaining plant and microbial life, regulating water and solutes, filtering and detoxifying contaminants, and storing and cycling nutrients. It's a complex system.
Absolutely. The sources also briefly touch upon how pesticide use, particularly in conventional or illicit farming where regulations are lax or just absent, impacts soil and water quality, something we'll definitely expand on in the water section. But there's a positive note here too, linking back to the plant itself. Phytoremediation.
Phytoremediation.
Yep.
That wonderful natural process where plants actually absorb contaminants from the soil. The source notes that cannabis does have phytoremediation capabilities. Why is that particularly relevant for the cannabis industry, do you think?
Well, it's critical for cultivation because growers often use soil amendments, composts, fertilizers, all sorts of things. This phytoremediation ability means the plant can absorb contaminants from those amendments if they happen to contain heavy metals or other pollutants.
No, okay.
So, testing your soil amendments for heavy metals before you use them is absolutely essential. You need to make sure you're not accidentally introducing pollution into your grow medium, which the plant could then suck right up.
Right. It highlights the plant's sensitivity and its interaction with its environment and really the grower's responsibility.
Mm.
Okay, so we understand the impacts. How do we address them? The sources lay out a whole range of best management practices, or BMPs, for land use and soil health.
It starts apparently with proper land use management right at the site selection stage. This means carefully considering environmental conditions like how close you are to water bodies or floodplains, assessing soil limitations like leaching potential or erodibility, looking at the existing vegetation cover, and understanding all the relevant regulatory and permitting aspects before you even think about breaking ground.
Then there are the actual farming practices aimed at building sustainable soil. The goal here is really to balance nutrient and water inputs and outputs, working with the soil's natural systems, not against them.
This involves practices like minimizing tillage, actively increasing organic matter content, managing pests through biodiversity rather than just reaching for chemicals, strengthening nutrient cycling through techniques like crop rotation or cover crops.
And being very judicious with chemical use, only applying what's truly needed and following labels precisely to avoid issues like bioaccumulation in the plant tissue itself.
And the payoff for doing all this: increased water and nutrient efficiency, which obviously saves money, potentially higher yields, and significantly reduced environmental impacts compared to conventional methods. Makes sense.
Increasing organic matter is really a cornerstone of sustainable soil health. The sources explain that organic matter is essentially all the once living plant and animal material in the soil. Earthworms and microorganisms decompose this into humus, that stable, dark material that does wonders like reducing erosion and slowly releasing nutrients over time.
And how do cannabis growers specifically do this? What do the sources suggest?
Methods like incorporating cannabis waste back into the soil, maybe mulching stems using leaves for their chemical and biological properties. They mention planting green manure crops like legumes or grasses that you then till back into the soil,
Huh.
spreading animal manure. But with a big caveat. You absolutely must test it first for pathogens or contaminants. Using organic fertilizers is an option, though they note this can sometimes be less cost-effective upfront than synthetic ones. Minimizing tillage, maybe using direct drill methods, and concentrating organic matter near the surface where it's most biologically active.
They also explicitly mention regenerative agriculture as a kind of holistic approach that improves soil quality, increases water absorption, decreases runoff, and increases organic matter retention over time. The source highlights that these techniques, while they might require initial effort, can potentially lower costs and increase sustainability in the long run, a connection that bridges soil health to water and waste management, which we'll definitely get to later.
Definitely. To reduce soil erosion specifically, which is a major concern, the sources recommend first calculating the erosion potential of your particular site and then adopting conservation measures related to water, wind, and tillage practices.
Specific techniques mentioned include contouring. What's that?
That's planting crops across slopes, perpendicular to the flow of water, creating sort of mini barriers that slow down water flow and reduce runoff. Using cover crop mixtures after harvest or over winter keeps the soil covered and protected when it's most vulnerable. And strip cropping involves alternating different crops in strips planted perpendicular to the prevailing wind or water flow direction.
All designed to keep that precious topsoil right where it belongs. And the sources emphasize the importance of soil testing. Seems obvious, but critical.
Absolutely critical. You should test your soil prior to the growing season, periodically during the season, and crucially test any amendments you plan to use before incorporating them. Don't just assume that compost is clean.
Why is testing so important beyond just knowing what nutrients are there? What else does it tell you?
Well, the sources list several key reasons. Optimizing production by providing the right nutrients in the right amounts, diagnosing problems like nutrient deficiencies or toxicities, protecting the environment by preventing runoff of excess nutrients or chemicals, improving the overall nutrient balance for healthier plants, and importantly, saving money and energy by only applying needed amendments instead of just guessing or using a generic recipe.
Makes sense. What should you test for?
You test for chemical properties like pH, electrical conductivity, EC, nutrient levels, and importantly, heavy metals. You test physical properties like particle size and density. And you also test for water-soluble nutrients and extractable or water-soluble heavy metals, because those are the forms the plant can actually take up and what might leach into your water.
And they mentioned accounting for soil depth changes over time and maybe cataloging different soil types on your property if it's a larger site. It sounds like a really foundational practice for any serious grower, legal or otherwise.
It absolutely is.
Hmm.
And don't forget testing your source water, too, a point we'll definitely revisit, but it significantly influences your soil and nutrient management strategy.
Okay, which flows nicely into integrated pest management, or IPM. The sources use the definition from UCIPM. It's an ecosystem-based strategy for the long-term prevention of pests and diseases using a combination of techniques. Sounds smart.
IPM is all about prioritizing the least toxic methods first. That means things like encouraging beneficial insects,
Hmm.
the good bugs that eat the bad bugs, using pesticides only as a last resort, and if you absolutely have to, choosing the least harmful options available. A core part of IPM is understanding pest life cycles and their weak spots.
Hmm.
And crucially, frequent monitoring, scouting your plants regularly to catch problems incredibly early before they get out of hand and become a major infestation.
The sources also tie IPM directly back to soil health, noting that a healthy living soil and a robust, well-nourished plant are your first and best line of defense. Pests, they say, tend to target weak or stressed plants. It's intuitive, really.
It's that holistic view again. And the Grow Guides add some really practical, organic IPM practices that are relevant for cannabis cultivators. Prevention is paramount.
Hmm.
Keeping the grow area spotlessly clean, sterilizing tools and pots between uses, quarantining any new plants you bring in, starting with pest-free soil or grow medium,
Right.
avoiding the common mistake of overwatering, which can invite root diseases and fungus gnats, and controlling the environment, especially humidity and airflow, to make it less hospitable to pests and mold.
Mm.
Oh, and a simple, often overlooked tip for the guides for indoor growing. Avoid tracking in pests on your outside shoes or clothes. Take your shoes off.
Oh, so practical. What about cultural controls?
That includes maintaining overall plant health through proper nutrients and watering, like we said, crop rotation if you're growing outdoors, which helps to break pest cycles, and increasing diversity like companion planting with things like basil or marigolds, which can repel certain pests or attract beneficial predators.
And mechanical or physical controls, just squishing them.
Pretty much. Things like hand-picking pests off plants if the infestation is small, or using traps. Like those sticky yellow traps you see, they're great for catching flying insects like fungus gnats or thrips, and they also serve as a way to monitor what pests are actually present and in what numbers.
And the guides mention organic sprays and treatments. Neem oil is a popular one, apparently effective against soft-bodied pests, and it has some antifungal properties too. But there's a strong caution, right?
Is a very strong caution.
Yeah.
Never use neem oil on buds past the early flowering stage because the oily residue can seriously affect taste and quality, and nobody wants that.
Definitely not.
They also suggest insecticidal soap, which can act as an emulsifier to help neem oil mix with water or be used as a mild pest control itself. And dilute hydrogen peroxide or potassium bicarbonate sprays are mentioned for mold prevention, again with a caution about using them carefully on buds, especially late in flower.
And biological controls, like releasing ladybugs.
Exactly.
Yeah.
The guides talk about releasing predatory insects like ladybugs. The sources even mention growers using ladybugs effectively in mid-flower to tackle stubborn mite infestations.
Wow, okay.
And the beneficial microbes in a healthy soil system are also considered a form of biological control against soil-borne diseases. So the overall IPM philosophy is integrating these multiple methods, prevention, cultural, mechanical, biological, and only then maybe targeted organic sprays to avoid synthetic pesticides entirely and keep the whole ecosystem in balance. As one guide puts it, it's an ounce of prevention.
Is worth a pound of cure. And definitely better for the environment and the final product. Okay, finally, on land use and soil, what about policy considerations? How can regulations support sustainability here?
Well, policies can promote land and soil sustainability by incentivizing and sometimes even requiring sustainable soil management and regenerative agriculture practices. They can also regulate pesticide use much more strictly than in conventional ag and actively promote IPM adoption through education and support programs for growers.
There's also a unique policy challenge specific to cannabis mention. pollen drift between hemp and marijuana farms.
Ah, yes. This is a fascinating, really complex problem highlighted in the sources. Because hemp and marijuana are the same species, Cannabis sativa, hemp pollen, can pollinate nearby marijuana plants. Now, this isn't an environmental contaminant in the typical sense, like a pesticide,
Right.
but it has major economic consequences for marijuana growers. Pollination drastically lowers the valuable cannabinoid content, especially THC, and causes the female plant to produce seeds, which basically ruins the value of the flower for commercial sale. Smokers don't want seeds.
And here's where it gets really interesting and kind of surprising from the source. Cannabis pollen can actually drift hundreds of miles on the wind.
Hundreds of miles. It makes the problem incredibly difficult to contain geographically. The source mentions an example of an Oregon lawsuit where one hemp farm actually sued another over pollen contamination.
A real-world example of the economic fallout. So what are the proposed policy solutions? Fences aren't going to cut it if pollen travels hundreds of miles.
No, definitely not. Solutions include things like requiring hemp farms to cull male plants to prevent pollen production in the first place, or implementing setback requirements mandating a minimum distance between hemp and marijuana grows. The source suggests around 4 miles might be needed.
Over miles.
Yeah, but then it immediately notes the experience in Pueblo, Colorado, where even that distance apparently wasn't enough, with estimates of 12–18% of marijuana crops still being affected by drift from hemp fields further away.
Wow. So it shows that even with policy, nature finds a way, and truly effective solutions might require a combination of really strict controls, maybe significant distances, perhaps zoning, and maybe even genetic solutions down the line, like sterile male hemp plants.
Could be. It's a tricky one.
So land use and soil health involve navigating challenges from illicit practices, implementing really detailed BMPs from site selection all the way to IPM, and tackling these unique policy issues like pollen drift. Okay. Ready to plunge into the next area. Water impacts.
Water impacts. Yeah, this is often the first environmental issue people associate with cannabis, isn't it? Conjuring images of these incredibly thirsty plants guzzling water. The sources directly address this narrative.
And they point out that this perception largely stems from studies of those illicit farming operations we talked about earlier, often located in really water-limited areas of Northern California, and often studied during major drought seasons. Kind of a perfect storm for bad data.
Exactly. And the problem with those early estimates is they were often based on scaling a single plant's theoretical water demand up to the observed density of plants on those unregulated farms. The sources argue pretty strongly that using a single plant-based estimate isn't really appropriate for the regulated industry because of the sheer variety of cultivation practices. Indoor, outdoor, mixed light, different plant arrangements, different harvesting strategies, all these drastically alter actual water demand per pound of product.
Right. And indoor grows, for example, often use less water overall because you can have these controlled recirculating environments.
Precisely. So the conclusion from the sources is that water impacts need to be evaluated locally because water availability regulations and usage needs vary so much by region. And whether growing is primarily indoor or outdoor in a specific region heavily influences what kind of water regulations are most appropriate locally. You can't just have a blanket national rule.
Makes sense. You can't regulate a grow in Arizona the same way you regulate one in, say, Oregon.
Absolutely not.
Yeah.
Now let's look at the environmental impacts of water use itself as detailed in the sources. Beyond just the volume used, the actual demand is influenced by a ton of factors. Indoor versus outdoor growing, local water availability, soil quality and type, environmental conditions, temp, humidity, sunlight, whether you start from seed or clone, the types of amendments used, and crucially, the extent to which water is recycled.
And it's not just the amount, but how it's used. Large-scale irrigation, especially if it's not properly managed, can cause sediment loads and erosion, washing soil and pollutants into watersheds. This is a particular risk from poorly planned projects or using things like surface irrigation on uneven ground without proper grading.
Fertilizer use is also deeply linked to water management. Excess or improper fertilizer use pollutes air, water, and soil. And poor irrigation, where water drains too quickly through the soil or medium, can leach valuable nutrients out of the root zone, creating this kind of a negative feedback loop where the grower thinks they need more fertilizer, requiring even more water to apply it, and increasing the risk of nutrient runoff pollution.
The sources also connect irrigation practices to pesticide use and the risk of monoculture. How does that work?
Well, irrigation, especially overhead watering or very humid environments, can increase humidity levels around the plants, which favors certain pests and diseases like molds and mildews.
Yeah.
And monoculture, planting vast areas with just one crop, which is common in high-value irrigated crops or often seen in illicit farming, increases the risk of widespread pest outbreaks.
Because there's no biodiversity to keep things in check.
Exactly. This can lead to heavy or frequent pesticide use, which, even if restricted in legal markets, can pollute water through leaching down into the groundwater or running off into surface water and pollute the air through vaporization, especially if growers lack proper training on application methods and safety.
Heavy metals in the water source can also be a concern, similar to the soil issue we discussed. And finally, wastewater. Commercial operations generate wastewater from irrigation runoff, cleaning, processing, and discharges to municipal sewer systems, surface water, or groundwater can cause significant problems if not properly treated or managed.
Right, you need to meet specific discharge criteria, control the flow volume, that's called flow equalization, and often adjust pH levels before it can be safely released.
Clearly, it's a complex system where everything is connected: soil, water, nutrients, pests. How do we address these water impacts? What are the BMPs for water conservation and quality?
It really starts with operational design from the ground up. The sources recommend a value engineering approach, basically designing the facility and processes to minimize resource use and costs simultaneously right from the start. For indoor grows, selecting grow bases or media with high water retention and low evaporation rates, like living soils, again, linking back to soil health is a key strategy.
And for outdoor grows, how do you estimate water needs there?
They suggest using established models like the FAO 56ET-based approach. ET stands for evapotranspiration. These models use local weather data, temperature, humidity, solar radiation, wind speed to estimate how much water the crop actually needs. The Food and Agriculture Organization of the UN provides the framework for these models.
That sounds much more precise than just guessing or watering on a fixed schedule.
It is. It's also absolutely critical to consider local water availability and capacity when selecting a grow location, and to understand all the required permits, allocations, or authorizations. Water rights, especially in arid regions of the West, are incredibly complex and often don't automatically transfer with the land title. You might buy land, but not the right to use the water on or under it.
That's a massive point for anyone planning outdoor cultivation in the Western U.S. Huge potential pitfall.
It really is. Researching and testing your water quality is also essential, both your incoming source water, well, river, municipal, and at the point of use after any treatment you might apply. Surface water quality, like from a river, can vary significantly seasonally with rainfall and runoff, much more so than groundwater or a public water supply.
So having some raw water storage capacity, like a tank or pond, can help buffer those variations in source water quality.
Exactly, it helps equalize things and ensure you're using proper dilution and application schedules for nutrients and cleaning solutions to avoid waste and pollution. Plus, make sure you obtain any necessary permits for water tanks or storage facilities, which are often required.
What about broader water conservation practices?
The sources mention voluntarily adopting techniques from regenerative agriculture that improve soil absorption and decrease runoff, like cover cropping and mulching. These practices reduce the need for inefficient irrigation in the first place. Some farmers are even experimenting with dry farming techniques, trying to rely more on natural soil moisture and minimizing external water inputs, although that's challenging for cannabis.
Optimizing the irrigation system itself seems like another key BMP.
Definitely. Select the proper system for your local climate and crop needs, evaluate any outdated systems you might inherit, and use current best practices like drip irrigation, precision pivot systems, or maybe even carefully managed flood irrigation in some contexts. Newer technologies like micro-irrigation or sub-irrigation, watering from below, are presented as good alternatives for arid or semi-arid regions.
And automation comes up again here?
Yes, automation is highlighted as critical for reducing water waste and decreasing variability in application. While the immediate financial or product quality return on investment might seem higher for larger facilities, the source mentions over 2,500 square feet as a rough threshold. Automation benefits all sizes for accuracy and efficiency. Plus, the data collected from automated systems, how much water was used when, soil moisture levels, etc., is invaluable for optimizing practices not just on one farm, but potentially industry-wide if shared.
And crucially, ensure your irrigation doesn't cause runoff by using systems capable of uniform application with minimal evaporative loss. New tech in this area continues to improve efficiency and reduce the volume of drainage water that then requires management or disposal.
Water treatment is also a major consideration, especially for indoor or recirculating systems where you're reusing water. Carbon filtration is mentioned as efficient for removing common contaminants like chlorine, sodium, or bicarbonate from incoming municipal water, with relatively low waste generated. Reverse osmosis, RO, sterilizes water very effectively but generates a substantial waste brine stream as a byproduct, which needs disposal. UV sterilization is presented as an effective method for avoiding contamination in recaptured water intended for reuse, killing pathogens without adding chemicals.
Speaking of which, water recycling and reuse are important BMPs highlighted. Things like HVAC condensate and dehumidification water from indoor grows can often be reused, as it's typically quite clean, though it might need some simple treatment just in case.
Captured excess irrigation water, however, the runoff or leachate from the pots or beds should always be sampled and tested before reuse. Why? Because there's a significant risk of accumulating salts, microbial pathogens, fungi, or chemical residues from fertilizers or pesticides.
So, using holding tanks helps equalize spikes in that captured water quality and volume, allowing for proper testing before it's potentially reintroduced into the irrigation system.
Exactly. The feasibility of recycling captured irrigation water depends heavily on its quality and the type of irrigation system you use. Generally, less treatment is needed for water captured from a drip irrigation system where the water only contacts the root zone compared to runoff from spray irrigation where it contacts the entire plant and might pick up more contaminants. And even if it's not suitable for irrigation, recycled water can sometimes be used for other non-potable purposes, like washing floors or equipment.
What are the treatment options for captured water before reuse?
Filtration to remove particulates is usually the first step. Then, for disinfection against common root and soil-borne disease pathogens like Pythium, Phytophthora, Fusarium, or Rhizoctonia, options include UV sterilization, ozone treatment, or copper-silver ionization technologies. And capturing and using rainwater should also be explored where feasible, but again, it needs to be tested for pH and potential contaminants like atmospheric deposition.
The ultimate goal for wastewater quality seems to be maximizing recycling and reuse on-site to minimize the volume of water that actually needs to be discharged off-site.
That's the ideal, yeah. Any water that is discharged needs to meet specific criteria, whether it's going into a municipal sewer system, directly to surface water like a creek, or potentially into groundwater via leach fields.
Okay, let's talk policy on water. What do the sources suggest?
Well, regulations need to set usage limits and stipulate disposal requirements that are appropriate for the specific geographical area and its water resources. Recognizing and navigating those complex state-level water rights systems is absolutely critical, especially in the western U.S., as we discussed.
And the sources suggest policies should not create unnecessary barriers for cultivators to access legal water markets. Why is that important?
Because if legitimate access is too difficult or expensive, it could inadvertently push growers towards relying on environmentally marginal or even illicit methods for obtaining water, which defeats the whole purpose of regulation.
Right. Mitigating reliance on potentially unsustainable groundwater sources by developing or increasing access to more complex surface water networks or recycled water systems is particularly critical for outdoor grows, which are often located in rural areas isolated from existing infrastructure. The source points out that really addressing this infrastructure gap might require federal descheduling of cannabis and regulation by agencies like the EPA, which currently can't fully engage.
Interesting point. And the sources propose that cannabis water regulations should largely mirror general agriculture standards for outdoor and indoor grows where applicable, leveraging existing knowledge and frameworks instead of reinventing the wheel unnecessarily. Policymakers, they say, need to understand their local watershed dynamics, actively incorporate BMPs into regulations, include resource and financial incentives to encourage adoption, and provide ongoing education to growers.
Absolutely. Water is such a precious and often limited resource, especially in many cannabis-growing regions. Managing its use and quality effectively is paramount for the industry's long-term sustainability and for moving definitively away from the environmentally destructive practices often seen in the illicit market.
Well said.
Right. And water isn't the only resource under pressure. Let's shift gears entirely and look at energy impacts. The sources make it very clear this is another area of significant environmental consideration for the industry.
It certainly is. The cannabis industry utilizes a whole range of energy infrastructure across indoor, outdoor, and greenhouse facilities, and depending on the production methods chosen, it can be incredibly energy intensive.
Indoor operations especially stand out here, right? The source notes they are disproportionately energy intensive. Why is that?
It's primarily due to the need for high-intensity artificial lighting, often running 12-18 hours a day, and the need for precise environmental controls, heating, ventilation, air conditioning, HVAC, and dehumidification. The source mentions a potential energy use of up to 5,000 kilowatt hours of electricity per kilogram of dried flower output.
5,000 kilowatt hours per kilo. That number is quite striking when you think about the scale of the industry and how many kilos are produced. Innovation in energy-efficient practices absolutely crucial to reduce the greenhouse gas emissions associated with generating all that power.
Absolutely. And the first step, as the sources emphasize again and again, is basic data collection monitoring your energy use. You simply can't improve what you don't measure.
A significant challenge highlighted is access to the main electricity grid for cultivators in more remote rural areas. This often leads to reliance on inefficient and polluting fossil fuel generators, diesel or propane. These not only use a lot of fuel, but also directly impact local air quality, which links to our next section.
Right, and even facilities that are connected to existing grids contribute significantly to overall electricity demand. In some areas, this added load from multiple cannabis facilities can strain the grid and may require expensive infrastructure maintenance or upgrades by the utility. And remember, energy use isn't limited to cultivation. Post-cultivation activities like extraction, manufacturing products, and transportation also require significant energy inputs.
So, the increasing electricity demand from the cannabis industry can challenge grid resiliency in some areas and directly impact state energy efficiency and greenhouse gas reduction goals. States are trying to lower emissions, and suddenly this new energy-hungry industry pops up.
It's a real challenge. It's critical for regulatory agencies and utility companies to work with growers proactively to help them reduce their consumption, manage their peak demand when they use the most power, and improve overall energy efficiency. This kind of collaborative effort is needed to ensure state climate goals can be met even as the industry continues its rapid growth.
So, what are the BMPs for achieving more efficient energy use, according to the sources?
Well, it starts with prioritizing economically viable and sustainable infrastructure decisions right from the outset when designing or retrofitting a facility. Applying zero-carbon electricity requirements where feasible, or strict energy efficiency standards, particularly for controlled environments like indoor and some greenhouse operations. Supporting distributed renewable energy projects like installing solar panels right there on site, the source includes an image showing a great example of a facility doing just that, covering its roof with solar.
A tangible example. Nice.
Exactly. Motivating energy conservation through utility rebates for purchasing efficient equipment lights, HVAC is a proven strategy that works in other industries. Ensuring cultivators have access to community solar gardens or similar shared renewable energy models can also help them offset their energy use with renewables, even if they can't install panels directly on their own site due to space or ownership issues.
HVAC efficiency is a major focus for indoor grows given the climate control demands. The sources recommend integrating dehumidification equipment directly with the central HVAC system. Why is that better than just using plug-in dehumidifiers?
Because those portable dehumidifiers, while they remove moisture, also inject significant heat back into the grow space as a byproduct of their operation. This forces the main cooling system, the AC, to work even harder to remove that extra heat, ultimately using more total energy. Integrated systems handle both cooling and dehumidification more efficiently.
Makes sense. What else for HVAC?
Protecting ventilation equipment with return air filter banks to prevent dust and plant matter from clogging coils and impeding airflow is a simple but crucial maintenance practice. And implementing comprehensive maintenance programs for those filters, monitoring the pressure drop across them, replacing them routinely, prevents the whole HVAC system from working inefficiently against clogged filters. Designing high-performance HVAC means going beyond just meeting minimum building code requirements, really understanding the sequences of operation, validating the system's performance after installation through commissioning, and continuously monitoring operational data like airflow, temperature, and relative humidity during operation to fine-tune it.
Lighting is the other major energy hog indoors. The primary strategy mentioned is converting to LED lighting systems.
Right. LEDs use significantly less electricity and, crucially, produce substantially less waste heat compared to older, high-intensity discharge HID lights like high-pressure sodium, HPS, or metal halide, MH, that were traditionally used.
And that reduction in heat load is key, right? Because it also reduces the energy needed for cooling the space.
Exactly. It's a double benefit. However, the sources add an important caution. Simply swapping out old lights for LEDs in an existing facility, a retrofit might require modifications to the HVAC system. If the original HVAC was designed for the constant high heat load of HID lights, it might not handle the lower, possibly more variable heat load from LEDs efficiently. Rapid cycling on and off can be hard on HVAC equipment and cause undesirable temperature and humidity swings in the grow room.
So you need to analyze the costs and system interactions first before just swapping lights.
Definitely. Interestingly, they note that matching the heat load of new LEDs to existing fixtures is possible in vertical indoor cultivation setups, where you stack multiple tiers of plants.
Yeah.
Because LEDs run cooler, you can potentially add more tiers of lights and plants in the same vertical space without overloading the cooling system, effectively increasing your yield per square foot and using energy more efficiently per pound of product.
Clever. Okay, what about policy interventions specifically aimed at energy? How can regulators help?
Policymakers need to be proactive here. They should set specific energy use targets or climate goals for the cannabis industry and communicate them clearly to operators. Incorporate energy efficiency standards and operational BMPs directly into licensing requirements and ongoing regulations. And importantly, provide structural and financial support, things like grants, low-interest loans, tax incentives to help operations, especially smaller ones, afford the often significant upfront costs of adopting these more efficient technologies and practices.
Data collection and analysis come up again here as essential. Why is that so important for energy policy specifically?
The sources stress this point repeatedly for energy. It's essential for measuring the effectiveness of efficiency programs, ensuring compliance with regulations, and enabling enforcement, benchmarking performance across the industry so operators can see how they compare, updating energy targets as technology improves, and critically sharing anonymized data publicly or between states to help accelerate efficiency gains across the entire industry much faster.
Market education is also highlighted as vital. States should support educational programs, maybe state-sponsored forums, targeted training workshops, helping businesses understand the state's climate goals and how adopting efficiency measures can actually improve their bottom line, their profitability over time. It's not just about compliance, it's good business.
Right, and ensuring utilities have the necessary funds, resources, and tools, like efficient interconnection processes for rooftop solar, effective load management programs to help growers shift energy use away from peak hours, and a reliable backup power services is key. The sources highlight a kind of technical knowledge and customer service gap that sometimes exists between traditional utilities and the specific needs of cannabis cultivators that needs to be actively addressed.
How should utility programs be designed to be most effective for growers?
They suggest offering prescriptive rebate programs for common horticultural lighting and HVAC equipment. These are generally easier for cultivators to access than complex custom rebate programs, which often require expensive, detailed engineering analysis that many smaller growers simply can't afford or don't have the expertise to manage. Make it simple.
And finally, incentives beyond just rebates.
Yeah, things like voluntary certifications, recognizing environmentally conscientious cultivators, maybe branding them as climate champions or something similar. Financial incentives for innovation in energy efficiency and rewarding responsible actors, potentially funded through industry taxes or membership fees. Tax credits, carbon credits, green energy certificates, technology innovation support. Grants the sources suggest modeling these after successful programs that have driven growth in the renewable energy industry itself.
And importantly, they emphasize prioritizing social equity and policy development and implementation again. How does that apply to energy?
By ensuring equitable access for small and minority-owned businesses to these energy efficiency incentives and resources. This might mean dedicated funding pools, targeted education, or business support services so they aren't disproportionately burdened by the costs or complexities of transitioning to more sustainable, energy-efficient operations. We need to make sure the drive towards sustainability doesn't leave these communities behind.
Energy is clearly a major environmental hotspot, particularly for indoor cultivation. But the sources present clear technological, operational, and policy pathways to significantly reduce the industry's impact. Okay, let's move on to air quality. What are the primary sources of air emissions from this industry, according to these sources?
Well, the most prominent natural source is actually the cannabis plants themselves. They naturally emit terpenes, which are a form of biogenic volatile organic compounds, or VOCs. These emissions are very site-specific. They vary a lot by the particular cultivar or strain being grown and the age of the plant. And they typically peak during the flowering stage when the buds are developing.
And here's another slightly counterintuitive point from the sources. Emissions apparently actually continue after harvest, during the trimming, drying, and curing processes. And they are expected to be higher during this post-harvest period than during active growth. Is that right?
Yeah, that's what the sources indicate. Those volatile terpene compounds continue to off-gas as the plant material dries and cures. The growing guides indirectly touch on this by discussing the importance of carefully managing the environment. Temperature, humidity, airflow during drying and curing, not just for preserving quality and preventing mold, but also implicitly to manage this off-gassing process. Beyond the plant itself, cannabinoid extraction processes, whether they're mechanical like pressing rosin or chemical using solvents like ethanol or butane, can also release VOCs and potentially fine particulates into the air.
Okay, and the environmental impacts on air quality. What are the main concerns?
Well, we already mentioned that relying on fossil fuel generators for power in off-grid locations emits greenhouse gases and other conventional air contaminants like nitrogen oxides and particulate matter. The VOC emissions, whether they're from the plants naturally or from extraction solvents escaping, contribute to the formation of ground-level ozone, which is a major component of smog and harmful to human health and ecosystems. Chemical extraction processes specifically can release residual solvents and other process emissions if not properly contained.
And then there's the big one that impacts neighbors directly, odors. That seems to be a huge point of contention.
Odors are a significant air quality issue, absolutely. They're primarily linked to those emitted terpenes we talked about, but potentially also other more potent sulfur-containing compounds that can be present in trace amounts. And odors are notoriously difficult to quantify accurately. Detection thresholds for the human nose are incredibly low for some compounds, and individual sensitivity varies wildly from person to person.
So what smells strong to one person might not even be noticeable to another.
Exactly. And odors aren't just unpleasant. They can be a major nuisance, impacting the quality of life for neighboring communities or even their livelihood in some cases. The source cites a fascinating, if problematic, example of Oregon vineyards actually suing a proposed cannabis cultivation facility due to fears that foul-smelling particles, their words from the grow, could potentially drift onto their grapes and taint the quality and flavor profile of their wine.
Wow, that's a real-world instance of how air quality issues, specifically odor, can create significant legal and economic conflict between different industries using the same airshed. Do the sources talk about how odors are measured?
Yes, they discuss current odor detection methods, but note the limitations. Odorimeters, which are handheld devices, often have limited reliability for complex mixtures like cannabis terpenes. Odor panels, where a group of people evaluates the intensity and character of an odor, are subjective by nature, and there are technical challenges with cannabis because terpenes tend to stick to the surfaces of sample bags, potentially altering the sample before the panel evaluates it. The conclusion is that more research is needed to develop reliable, objective methods for quantifying cannabis odors specifically.
The sources also mention CO2 use in cultivation, sometimes sourced from industrial processes. There's a colorful anecdote about craft breweries selling their waste CO2 to nearby pot growers.
Yeah, a nice example of potential industrial symbiosis, reusing a waste stream. Though it's worth noting that fermentation, while producing CO2, can also create other potential contaminants, like hydrogen sulfide or methane, so that CO2 likely needs purification before being used in a grow room or for extraction.
Right, resourcefulness. But
Gotcha.
you have to be mindful of purity. Okay, so how do we manage these air quality issues? What are the BMPs?
For extraction facilities, emission control technologies and proper solvent management are absolutely key. Using things like condensers, cold traps, and fully closed-loop extraction systems helps conserve expensive solvents and significantly reduces fugitive emissions into the air. Extraction facilities should have rigorous protocols, regularly inspect and maintain their solvent storage tanks and the extraction systems themselves for any leaks, prevent leaks during solvent transfer operations, and never dispose of spent solvent by simply letting it evaporate or spilling it.
How should they handle spent solvent?
It should be recovered within the closed-loop system or collected in a designated sealed waste container for proper hazardous waste disposal or recycling. They also recommend trying to quantify air emissions, perhaps via a mass balance approach, basically tracking solvent purchased minus what's still in inventory minus what's accounted for in the product equals what's likely lost to evaporation to determine if emissions are significant enough to require a formal air permit from the local authority, and contacting that authority if they are.
Okay, that makes sense for extraction. What about managing VOCs and odors from the cultivation and drying curing areas?
Control technologies are highly recommended here, and in some jurisdictions, like Canada under their Federal Cannabis Act, they are actually required by regulation. The most common technology discussed is activated carbon filters.
How well do those work?
Carbon filters are widely used, generally effective, and reliable if they are properly sized, installed, and maintained, meaning the carbon needs to be changed out regularly. They use porous activated carbon material that absorbs VOCs and other odorous gases onto its surface. However, their performance can be significantly inhibited by high heat and especially high humidity, which can clog the pores.
So they might not work as well in a really humid grow room. What are the best practices for using them?
The sources recommend designing the filter system specifically for your facility's airflow, and expected odor load consulting an HVAC expert with cannabis experience is advised. Choose filters with appropriate efficiency ratings from a reputable manufacturer. Ensure you don't exceed the maximum airflow rate specified for the filter, because that reduces the contact time the air has with the carbon, making it less effective. Regularly inspect and replace the carbon media based on manufacturer recommendations, detected odors, or a set schedule. And ideally, time the replacement to occur just before the peak ozone season in your area, often starting in early May, as VOCs contribute to ozone formation. Using pre-filters to capture dust and larger particles also helps extend the life of the more expensive carbon filters.
Okay, carbon seems like the main workhorse. What about chemical additives, things like misters, foggers, and vaporizers, or MFV systems?
Right, these are another option mentioned. These systems inject or spray substances, often based on plant essential oils, into the exhaust airstream, usually near large roof vents, to interact with the odors before they leave the building.
And how do they work? Do they destroy the odor?
Well, there are different types. Odor-absorbing neutralizers are misted into the exhaust air. These are typically plant extracts or sometimes synthetic compounds designed to chemically react with or neutralize the odorous VOCs, potentially also reducing their contribution to ozone formation. A critical caution from the sources. These neutralizers cannot be used inside the grow room itself, as they could potentially absorb onto the plants and negatively impact the taste or smell of the final product. Their effectiveness varies by product and requires sufficient contact time in the exhaust stream.
What about other types like masking agents?
The sources also mention masking agents and counteractive agents, but explicitly note that these methods actually add more VOCs to the ambient air, which is generally undesirable from an air quality perspective. Masking agents simply release a stronger, more pleasant odor to try and overpower or overload your sense of smell for the cannabis odor. Counteractive agents supposedly bind with the smelling compounds or somehow block your olfactory receptors. Because they don't eliminate the VOCs and actually add more, they're generally not recommended, particularly in urban areas where adding any unnecessary VOCs to the atmosphere is problematic.
Good distinction. Are there any other technologies mentioned?
Mineral filters and biofilters are discussed briefly as emerging technologies. Mineral filters use proprietary granulated minerals and are claimed by manufacturers to have advantages over carbon in high humidity or heat, but the sources say not much independent information is available yet for their specific use in cannabis. Biofilters use an organic medium, like wood chips or compost, populated with a bacteria biofilm that consumes odorous emissions. They're used traditionally in industrial agriculture or wastewater treatment. R&D is apparently exploring bacteria that can specifically consume terpenes without harming the plants. However, biofilters require a relatively large physical footprint and careful control of moisture and temperature. Based on the information available at the time of the sources, they currently do not recommend mineral filters or biofilters for cannabis applications until more data and real-world experience are available.
So, activated carbon filters, possibly supplemented by carefully chosen odor neutralizers in the exhaust stream, seem to be the most established and recommended BMPs for odor and VOC control right now. What about policy considerations for air quality?
Robust interagency communication is highlighted as key. The sources emphasize the need for a strong network and clear communication channels between diverse agencies. The regulatory bodies setting air quality standards, agriculture departments, law enforcement, education, natural resources, police, transportation, even the Treasury Department involved in licensing and taxes for effective regulation, compliance monitoring, enforcement, and quickly identifying and responding to air quality problems or complaints.
So when someone applies for a cannabis license, the review process should include assessing all applicable environmental regulations, specifically including any necessary air permits for emissions or odors.
Exactly. And supporting incentives for innovation and environmentally responsible actors is crucial again here. This could involve financing or technical assistance programs specifically tailored for individuals and businesses who might face barriers to entry, or affording expensive pollution control technologies, for example, formerly incarcerated individuals participating in social equity programs, or small and minority-owned businesses who might find permit fees, or the time required to navigate the complex air permitting process particularly burdensome.
These policies help ensure that air quality impacts, including managing those tricky odors, are addressed systematically across the industry and hopefully equitably.
Absolutely. Addressing emissions, whether they're VOCs, greenhouse gases from generators, or just nuisance odors, is really vital for the industry's social license to operate, its relationship with its neighbors, and the wider environment.
Okay, makes sense. Finally, let's plunge into waste impacts. This seems like an area that could quickly become a major environmental challenge given the sheer scale and rapid growth of the industry we've been talking about.
It's a significant concern, no doubt. The sources note that while best management practices in legalized cannabis have understandably focused heavily on public health and safety, initially, things like preventing diversion to the illicit market, testing for contaminants,
Right, the immediate priorities.
exactly.
Hmm.
But the environmental impacts from generating industrial-scale waste are now demanding much more attention.
What are the major waste streams identified in the sources?
The two biggest ones are plant byproduct from cultivation and trimming stems, fan leaves, root balls, maybe unsold or expired product, and then consumer packaging waste. Those are the biggies.
But there are others too.
Oh, yeah. Additional streams include things like spent extraction solvents, used grow media like rock wool, cocoa coir, or soil that's being replaced, mercury-containing lighting and ballasts from older lighting systems that get swapped out, vape cartridges and the batteries that power them, and other electronic waste from pumps, controllers, computers, etc. The estimate mentioned in the source for the entire North American cannabis industry, including resource extraction and energy use associated with it, generating over 1 million tons of waste back in 2019 alone, is quite stark.
1 million tons of waste in a single year. That's a truly staggering figure. The sources call for a unified and innovative vision for the industry to truly lead on sustainable practices, and waste is clearly a key area where that leadership is desperately needed.
Definitely. Let's break down plant waste first, the stalks, leaves, roots. This typically ends up in landfills. Why? Because regulations in many states require it to be rendered unusable and unrecognizable before disposal, often by mixing it 50% with non-marijuana waste like cardboard or food scraps. This mixing requirement makes traditional large-scale composting challenging and often not economically viable.
So what's the alternative? Are there better ways emerging?
An emerging best practice mentioned is on-site anaerobic digestion. This process uses microorganisms in an oxygen-free environment to break down the plant waste. It generates biogas, primarily methane, which can be captured and used to generate heat or electricity for the facility. It also captures CO2, which could potentially be purified and used back in cultivation or for CO2 extraction. And the leftover solid material, the digestate, is often a nutrient-rich substance that can be used as fertilizer. So it offers potential for 100% diversion from landfills and significant resource reuse.
That sounds promising, like closing the loop.
It is promising, although the technology requires significant capital investment. Another practice, linking back to our soil health discussion, is incorporating cannabis waste directly back into the cultivation soil, maybe mulching stems, using leaves for their soil-benefiting properties. The challenge here, however, as mentioned in the source, is the very fibrous nature and high lignin concentration of cannabis plant matter. Lignin is tough and breaks down slowly, so it can prevent efficient breakdown in typical composting systems or if just tilled directly into soil without pretreatment.
So it might just sit there for a long time.
It could, or tie up nitrogen as microbes try to break it down. The ORSAs suggest a potential solution here, utilizing a specific microbial inoculant, a blend of bacteria and fungi, specifically designed to break down the complex cellulose and lignin in cannabis plant matter more quickly and effectively. This could help repurpose the biomass more readily as a valuable fertilizer or soil amendment on site, reducing costs for both fertilizer inputs and waste removal fees, and potentially promoting higher yields over time by improving soil health.
Interesting. What about disposing of hemp that fails THC testing? That's technically waste too, right?
Yes, non-compliant hemp disposal is a specific waste stream with federal regulations under the USDA. If hemp biomass tests above the 0.3% THC threshold, it's considered a controlled substance and must be disposed of using approved methods. These typically include disking or tilling it directly into the soil on the farm, or composting it according to specific protocols. Burning is generally discouraged due to air emissions. Stems should ideally be chipped or mulched first because of their high lignin content, which makes them break down slowly. Incorporating this exempt biomass back into the soil, if managed properly, actually promotes nutrient liberation and builds soil organic matter, which is important given the limited global supply of resources like phosphorus. But growers do have to follow the rules and report the disposal monthly to the USDA.
Okay, that covers plant waste. Now, moving on to consumer packaging waste. The sources called this a significant and rapidly growing stream, especially single-use plastics driven by requirements for child-resistant and often opaque packaging in many state regulations.
Yeah, the packaging issue is huge and very visible. The current U.S. recycling model is highlighted in the sources as being fundamentally broken and contributing to vast amounts of mismanaged waste, including plastics entering the environment. The projections related to plastics production and disposal globally are quite alarming. One projection mentioned suggests that by 2030, the greenhouse gas emissions from the life cycle of plastics could be equivalent to running over 295 large coal-fired power plants per year.
That's a massive climate impact just from plastic.
It is. And looking globally, a 2017 analysis cited found that of the roughly 8,300 million metric tons of virgin plastics ever produced up to that point, only about 9% had actually been recycled and 12% incinerated as of 2015. That left a staggering 79%, the vast majority accumulated in landfills or polluting the natural environment. The projection was that by 2050, there could be 12,000 million metric tons of plastic waste in landfills or the environment if trends continue.
Just mind-boggling numbers. Where does this mismanaged waste end up?
The sources pinpoint the root of the problem to the mass production of cheap, single-use disposable items and the inherent limitations of our existing recyclable materials collection and sorting model. Much of this mismanaged plastic waste, especially from developed countries, ends up being exported and sorted, often under poor conditions, by low-wage workers in developing countries. And ultimately, a significant portion is simply dumped or discarded into waterways and eventually flows into the ocean, with China and Southeast Asia historically being major recipients and sources of this ocean plastic pollution. Mismanaged waste is defined here basically as material that is littered or inadequately disposed of, not making it into a controlled landfill or recycling system.
And there's a particularly pointed discussion in the sources about packaging labeled compostable and biodegradable. You'd think that would be a solution, right?
You would think so, but the sources argue it's often not that simple, and can sometimes even be worse. They state that the vast majority of this material still ends up in landfills, where, lacking oxygen, it decomposes anaerobically and contributes to greenhouse gas emissions, specifically methane.
Worse than regular plastic in a landfill.
Potentially, yes, because the organic components break down and release methane, whereas conventional plastic is relatively inert in a landfill. And even more concerning, a literature review conducted by the Oregon Department of Environmental Quality, DEQ, which is mentioned prominently in the source, found that manufacturing and attempting to compost many single-use compostable items often result in increased overall environmental impacts, including energy use, water use, and greenhouse gas emissions, compared to their non-compostable counterparts handled via conventional recycling, landfilling, or incineration with energy recovery.
Increased environmental impacts. That absolutely flies in the face of common perception and marketing claims. How can that be?
It does seem counterintuitive. The reasons cited are layered. There's often an increased resource burden associated with producing the feedstocks for these bio-based materials, growing crops, processing them. And composting itself is often inefficient for recovering valuable nutrients or materials from human-made products compared to composting actual food scraps or yard waste. A major practical challenge is that many products labeled compostable, even those certified by organizations like BPI, fail to break down fully within the typical time frame and conditions of standard industrial composting facilities. They require very specific nuanced conditions and often longer processing times than facilities can provide.
So what happens to the stuff that doesn't break down?
It contaminates the finished compost. Compost facilities then have to invest in expensive screening equipment to remove this residual uncomposted material, which adds millions of dollars to their operational costs nationally. And where does that screened-out residual material go? Usually gets sent to the landfill anyway, where it then breaks down anaerobically and produces methane, a greenhouse gas, with roughly 25 times the global warming potential of CO2 over a 100-year period.
Wow. There's a quote from David Alloway of the Oregon DEQ included in the source that really drives this point home. What's missing from the discussion is the impact of making these single-use, compostable items. The fact that something is compostable is a useless predictor of environmental impact. The source even mentions that because of these issues, many commercial compost facilities in Oregon now refuse to accept compostable packaging products altogether.
It's a crucial, sobering insight. Simply labeling something as compostable or biodegradable doesn't automatically guarantee an environmental benefit, especially if the necessary collection infrastructure or effective processing conditions aren't widely available or economically viable. It might just be greenwashing.
So the BMPs for waste reduction need to move beyond this limited view of just switching materials for single-use items. The sources argue pretty strongly that the future really lies in transitioning away from the whole model of planned obsolescence and single-use packaging entirely. We need systemic change.
That's the core message. Strategies proposed include federal standardization for reusable or refillable packaging designs. Why federal? Because having inefficient, differing regulations across multiple states creates huge barriers for companies trying to design and implement widespread reusable systems that can work across state lines. Integrating regional take-back systems for reuse or proper recycling is also suggested, and implementing well-designed extended producer responsibility (EPR) schemes or deposit return systems for packaging.
What exactly is an EPR scheme again? How does that work?
EPR basically means that the producers of the packaging, the brand owners, the manufacturers, bear a significant financial and/or physical responsibility for the post-consumer phase of their products. That includes collecting, sorting, and ensuring the proper treatment or disposal, ideally recycling or reuse, of that packaging after the consumer is done with it. The sources argue this incentivizes waste prevention at the source, using less packaging, designing for reuse, encourages innovative, more sustainable design choices, and directly supports achieving state or national recycling and materials management goals. It holds manufacturers accountable for the environmental externalities, the pollution, resource depletion, climate impacts associated with their products throughout their entire life cycle, not just making and selling them.
Okay, so it shifts the burden from taxpayers and municipalities back to the producers. What other strategies are mentioned?
Promoting bulk sales models where consumers can use their own reusable containers, designing packaging explicitly with long-lasting reusable materials, and implementing take-back or deposit return programs directly at retail dispensary locations for specific packaging types.
What about waste from the cultivation side, beyond just the plant matter, like grow media or lights?
For indoor cultivation waste, the first BMP is to reduce the overall waste footprint compared to outdoor or greenhouse growing by simply choosing to grow outdoors or in greenhouses using passive solar design wherever the climate and regulations allow. If you are growing indoors, selecting reusable or genuinely compostable grow mediums and verifying your local composter actually accepts them, and ensuring that lighting fixtures are recyclable at end of life is key. They specifically note that rock wool, a common hydroponic medium, is particularly difficult to recycle and often ends up in landfills. Although some specialized composting facilities might accept it again, you have to check locally.
Lab waste from mandatory product testing is another significant stream. Mentioned all those little plastic pipette tips, tubes, culture plates, plus chemical waste and other potentially hazardous waste. What are the BMPs there?
Practices include investing in equipment that allows for washing and reusing pipette tips multiple times, like the specific device called the Granoka Tip Novus mentioned in the source, which can drastically reduce plastic waste. Participating in specialized recycling schemes offered by manufacturers for specific types of lab plastics, citing Kimberly-Clark's Right Cycle program as one example. On the chemical side, using less hazardous solvents wherever possible, green chemistry principles, reducing the overall volume of solvent used through process optimization, improving storage and handling practices to prevent spills, and ensuring proper segregation and disposal of chemical waste according to EPA guidelines and local regulations are all critical.
Vape waste is also specifically highlighted as a problematic hazardous waste stream. Why hazardous?
Because the cartridges often contain residual cannabis oil, which might still be regulated, and heavy metals from the heating coil components, like lead, and the lithium-ion batteries that power vape pens are themselves hazardous waste due to fire risk and heavy metal content. Developing and implementing clear best practices and accessible collection programs for the safe handling and disposal or recycling of vape carts and batteries is identified as an urgent need for the industry and regulators.
Okay, finally, policy considerations for waste management. What levers can be pulled?
Waste mitigation through mandatory EPR programs and/or deposit return systems for packaging is seen as a foundational policy tool. Federal standardization for reusable and refillable packaging designs is considered key to enabling scalable, efficient solutions that work across state lines. Encouraging the development and adoption of waste-to-energy systems, particularly anaerobic digestion for processing cannabis plant waste locally, is seen as a viable pathway for both waste diversion and resource recovery.
What about incentives?
Incentivizing regenerative systems and innovative technologies is crucial. This could include policies that help develop regional end markets for recovered materials or reusable packaging components, and potentially integrating energy recovered from waste, like biogas from anaerobic digestion, into federal or state renewable portfolio standards, RPS, to give it more value. Incentivizing extraction processes that demonstrate careful material management and have robust solvent recovery and management plans is also important. The sources suggest potentially encouraging solventless extraction methods like rosin pressing, or processes using less toxic solvents like supercritical CO2 extraction versus ethanol or hydrocarbon extraction, although they do note CO2 itself has greenhouse gas implications related to its sourcing. Perhaps through incentives like fast-track permitting or reduced licensing fees for facilities using preferred methods.
And broader financial incentives?
Yes. Introducing or strengthening policies for things like tax credits, tax cuts, carbon credits, or green certificates could also drive change in waste management, potentially funded by industry taxes or memberships. Specific tax incentives for businesses that adopt reusable packaging systems, invest in on-site waste-to-energy like anaerobic digestion, establish effective take-back programs, or demonstrate significant overall waste mitigation are suggested.
A national cannabis sustainable packaging certification program is also proposed. How would that work?
The idea is to create a clear standard that recognizes efforts towards more sustainable packaging. This certification would ideally evaluate solutions based on a hierarchy, recognizing recycling and composting efforts, but explicitly giving the highest value and recognition to reuse systems due to their significant environmental advantages over manufacturing new single-use items, regardless of whether those single-use items are claimed to be recyclable or compostable. It helps guide industry and consumers towards truly better options.
Regulating all waste streams clearly, including detailing specific requirements for things like non-compliant hemp disposal, is essential for consistency. And developing a federal self-reporting portal is mentioned again. How would that help with waste?
The idea is for growers and operators to be able to anonymously report key environmental metrics, including waste generation and disposal methods. This could provide invaluable aggregate data for benchmarking industry performance, identifying problem areas, and tracking progress over time without the immediate fear of penalty for reporting honestly. And finally, establishing material management protocols that integrate financial and sustainability reporting. The sources point out research showing that companies demonstrating good performance on material sustainability issues, like waste reduction, resource efficiency, have actually been shown to significantly outperform their peers financially. This suggests that investing in sustainability isn't just an environmental imperative, it's also potentially good for business and shareholder value in the long run.
Wow. So from plant waste to packaging and lab waste, the industry clearly generates substantial and varied waste streams. But the sources show there are comprehensive policy tools available, emerging technologies like anaerobic digestion, and crucial design strategies that can be implemented to address this, moving the industry towards a more circular and much less environmentally impactful model.
Absolutely. The sources lay out a pretty clear path forward, though it undeniably requires significant effort, investment, and coordination between industry players and regulators.
Okay, let's try and bring this deep dive to a close. Pulling back from all the incredible detail we've unpacked from your sources today, we've covered the significant environmental challenges facing the rapidly expanding cannabis industry. Things like land degradation and erosion from poor cultivation practices, especially those lingering from the illicit market era, water pollution, and potential overuse, again amplified by historical illicit methods but still a concern for legal grows, the very high energy demand, particularly associated with indoor cultivation, air emissions, including those tricky VOCs and difficult-to-manage odors, and these really substantial waste streams ranging from the plant matter itself to consumer packaging and hazardous lab or vape waste.
And throughout this, we've seen that the legal regulated market, simply because it is regulated, has the framework and at least the potential which the illicit market completely lacks to actually implement solutions for these challenges. The structure is there where it can be built.
We've explored a really wide range of existing and emerging best management practices across all these areas: land use, water, energy, air, and waste. Everything from detailed soil testing and integrated pest management
to water recycling technologies, super energy-efficient HVAC and LED lighting systems, advanced odor control technologies like carbon filtration, and innovative waste solutions like anaerobic digestion for plant waste or designing for reusable packaging. The tools exist.
And the absolutely crucial role of policy has been a consistent thread throughout our discussion, driving sustainability through smart regulations, providing targeted incentives to encourage adoption of BMPs, enabling vital data collection for tracking progress, supporting education for growers and operators, fostering better interagency communication, and emphasizing the need to support social equity in accessing and adopting these beneficial but sometimes costly practices.
Yeah, policy really provides the guardrails and the nudges needed to push the entire industry in a more sustainable direction.
We've even touched on some of the more nuanced and maybe surprising points raised in the sources, like the counterintuitive environmental impact of some packaging claimed to be compostable, the frankly amazing distance cannabis pollen can drift, the inherent challenges of objectively quantifying odor, or that subtle link between poor irrigation practices and needing more fertilizer, creating a negative cycle.
It's definitely clear that achieving genuine sustainability in this complex industry requires meticulous attention to detail and coordinated effort at every single step of the process, right from preparing the soil or selecting a grow medium, all the way through cultivation, processing, packaging, and the final disposal or reuse of materials.
And drawing on the conclusion from that NCIA report, the cannabis industry is uniquely positioned, isn't it? It's still a relatively young industry in its legal form. It's growing incredibly rapidly, and it's highly visible to the public and policymakers. It really does have a genuine opportunity to differentiate itself from older, more entrenched industries and potentially lead on sustainability, pushing for innovation and adopting a unified vision that could even serve as a kind of blueprint for other agricultural and manufacturing sectors to follow.
That potential is definitely there. It's exciting to think about. But let's be realistic. It's also up against significant economic pressures, the drive for profit, and it's still navigating this incredibly fragmented state-by-state regulatory landscape, plus the ongoing challenge of competing with an unregulated illicit market that simply doesn't bear these environmental compliance costs. It's not an easy path.
Which leaves us with a final provocative thought for you, the listener, to consider as this industry continues to evolve at lightning speed. Given its rapid growth and high visibility, can the legal cannabis industry truly fulfill that potential and become a genuine model for sustainable agriculture and manufacturing, maybe even pushing other sectors to adopt more environmentally conscious practices? Or will the economic pressures and the complex patchwork regulatory landscape ultimately make this potential hard to fully achieve widespread, meaningful impact? And perhaps most importantly, what role might your choices as a consumer play in demanding and supporting the businesses that really do prioritize sustainability over just the bottom line?
That's definitely something worth mulling over. The choices being made right now by businesses, by regulators, and by consumers will absolutely shape the industry's environmental future for decades to come.
A huge thank you again for providing the absolutely fascinating source material that made this deep dive possible today. It's been incredibly insightful to explore these critical environmental topics with you through this lens.
Our pleasure entirely. There is certainly a lot to learn from these documents, and clearly a significant path of improvement still ahead for the industry if it wants to live up to that sustainable potential.
We really hope this deep dive gives you a solid, nuanced understanding of the environmental landscape in the cannabis industry and encourages you to keep exploring these vital topics. We'll catch you on the next deep dive.